singly linked list, then we have doubly linked list. Okay, we have, it has some address, that is your address. Every node will have its own address like this in this case. So 2117 will be stored by the head pointer. The head is a pointer here. Hello everyone, welcome to our channel Coders Arcade. This is Ashank David, and in today's video we are going to talk about a type of a data structure called as linked list. So this video is going to be dedicatedly on linked list concept. So if you don't know about linked list or how to work with this is the right video you have come across. So without any further ado, let's get right into the topic. But before, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So now let's get right into the topic, guys. So first of all, we need to understand what is a linked list. Linked list is a concept in data structure which is supported in all the languages which supports data structures. It's a concept of collections in data structures, and using this you can store the elements into it, just like how an array works. So if you know what is an array and how an array works, let me just show you once. Here in this case we have an array, let's say. Okay, we have an array. Okay, let's say we are taking some 1 2 3 4, this is some array elements. Okay, now in this case this is an array. Now it is a collection in data structures. Well, array also is a concept of data structure which is used for storing the elements into it at one place. The problem with this array is that this size is fixed. So the size is fixed. Alright, when the size is fixed, the problem here is that you cannot just do the job flexibly in arrays. For example, if I want to insert something here, okay, let's say I want to insert 100 in between 2 and 3. What I need to do? I need to create either the another array with lots of space, one more element I can store, or I can just shift the elements like here or here. I can just shift the elements here. Okay, so in this case what happens is 3 will be shifted there. So in this case, say for example here now you want to your new array would come like this: 1 2 100 3, but the 4 will get deleted because the size of the array is always fixed. So this is the problem with the array, guys. Understood? So while you want to shift the elements, while you are inserting the element, you have to write a lot of code. So that is also one problem in arrays that we usually have, and that is the reason why we have a concept called as linked list, which works very similar to an array to store the data elements, but it's a buffed up version of an array only. Linked list is also a collection in data structures which allows you to store the data in different memory segments. And number one thing is that array has a fixed size, while linked list doesn't have a fixed size. You can have n number of nodes into it, and you can do a lot of things, a lot of operations into it, and you can do a lot of things. So let's understand what is this linked list in this case, guys. So I'm gonna just go ahead and I'm gonna write what is a linked list. So first let us talk about how many types of linked lists we have. Singly linked list, then we have doubly linked list. Okay, we have circular linked list. Okay, now different types of linked list can be in ordered or in ordered. Different types can be there, but in this video we will be morely focused towards the singly linked list type. Okay, doubly and circular we will be talking about that, but not in this video. In this video I'm just gonna explain you the logic behind how the linked list is working, and then we are gonna understand how it actually happens. Okay, so let me just make you tell how exactly linked list is working in this case. So let us talk about a linked list first. So guys, if I give you a basic idea of how a linked list looks like this. See, this is a node. This is square which I'm creating in a linked list. This is called as a node. Now every node is connected to each other in this case. Say for example, it is looking like this. This is gonna be a linked list node. Okay. So let's say I've created 4 nodes in this case. See, linked list is a collection of nodes which are linked together. Every node contains minimum I'm taking one partition here, and in this one partition, here the data is stored. Let's say I'm taking data as 20, 10, 30, 40 and so on. Okay, so this is going to be our data. Then let's say, see, array size is fixed, right? Array is generally one memory allocation with multiple different segments into it. So in this case, array is that. But in this case, in linked list is a collection of nodes, while each node possesses its own memory. So this is one allocation, this is another allocation, this is another allocation, this is another allocation and so on. Similarly, see, linked list doesn't have a fixed size. Unlike arrays, linked list doesn't have a fixed size. So in this case, there can be n number of nodes, there can be millions of nodes, n number of nodes as you want in this linked list. So you can store basically n number of data into it. That is one good part of how the linked list is working in this case. But let's understand it in much more detail. Let's go ahead and understand what exactly is going to be next in this case. See, I told that every node in linked list is going to be having its own memory space in this case. So every memory will have its own address also. So I'm going to take the address. So usually if you say what is an address, let's say I'm going to take an integer type of variable equals to something. Let's say int a equals to 10 I have taken. Okay. If I say cout in C++ and if I just print that ampersand of a, what it is going to print, this ampersand of a in the output, it will print something like this: 0, x, 6, e, f, b. See, this is going to be a hexadecimal number in this case, guys. This is your address. Okay, this is your address. But in this case, every node will have its own address like this. See, this is the named memory location. So it has some address, that is your address. Every node will have its own address like this in this case. Okay, so I'm going to rub this off as of for now. I'm going to show how it is going to work. See, every node will have its own address like 0x6 f e b c 0x28 b c d, something like that it will be. But it is going to actually confuse you, so I'm not going to take the address in hexadecimal values. What I'm going to do is I'm going to take the address in some random numbers. I'm taking some random numbers like 2117, okay, 2819, 2987, 2889. Okay, this number represents the address of each and every node in the memory space. All right, so this tells you the address of all the elements. Okay, this partition here where 10, 20, 30, 40 is stored is the data segment of every node, and the next part, the next empty part, will actually store the address of the next node. So if this is the node, then the address of the next node here will be stored as 2819. So 2819 is the address which will be stored here in this particular node's next. So this is going to be the data, and this is actually going to be the next pointer, which is going to actually point towards the next node. Similarly, here also in this node, what will happen? This is the data, this is the next node. Okay, so next pointer it is. Okay, which is going to actually point towards the next node. So here also it will come 2987. This address will come here. Similarly, this address will come here of this node. So 2889. And at last, when we don't have any node up there, we will say it as null. Okay, so this is going to be the last node next to be null. Okay guys, so now that once the last node's next becomes null, that type of node will be called as the tail node in the linked list. Okay, that is the tail node. And how we will get to know that which one of these nodes are the first or the head node? I'm gonna define a head pointer. A head pointer is always there, which is gonna actually point towards the first node. So let's say this is our first node. So 2117 will be stored by the head pointer. The head is a pointer here which always points towards the first element of the linked list, guys. Okay, this is gonna store the first element address in this case. Alright guys, now this is how your linked list looks like. Now let's say I moved this head from here to, I moved this head to here, let's say 2819. Now in this case, what will happen? This will become the first node. Okay, this will become the second node and so on. This node will not be taken into the consideration. So guys, it is very important for us to understand that how we work with the head. Head is a pointer which points towards the first node. So in this case, the head will only store the address of the first node. Always remember this, okay? So if the head is this node, head will point towards this node, okay? This is how a linked list is looking like. Now let us talk about the insertion. In the previous example of arrays, we understood that insertion is very difficult, and we lose some element into it, and that is the problem in the arrays. Array has a fixed size and so on. But in this case, linked list doesn't have a fixed size. So if I, let's say, want to store any or add any element here in between, let's say here in between this node and this node, what I can do is I can travel to that node, I can create a new node there, okay? I can create the new node there, and what I can do is, let's say this is our new node and the new node address is 2998, okay? Let's say I have stored the data as 60. I want to insert this 60 data here. In that case, what we will do, we will just create the node there. What we will do, we will just break the link in the between, and we will erase this address. We will write this new node's address here. That means 2998, which will result in connecting this node with this node, and then we will write the address of this node here. That means 2987, which will connect this node with this node, and hence you inserted an element in between without shifting any elements, without deleting any elements, and without losing any data from your collection. This is how your linked list works in this case, right? So this is going to be the easiest insertion. Well, this is why linked list is so much popular in terms of data structures, and it is better version of an array. Rather than using an array, you can use a linked list in this case. Talking about the insert at head, let's say you want to do insert at head. At that case, what you will do? Okay, now in that case, what you will do? Let's say this is our head. This is our head, right, of that linked list. Now what you will do is, you will first create the node there, okay? You don't have to travel to that node because already the function will start from the first, and you created that node. Let's say the data that you want to enter is 100. So you created that node. Right now the newly created nodes next will be null. In this case, what you will do, you will just point this n's newly created node. Let's say this is 2818, okay? Let's say this is the newly created node. You will rub this null and you will point this to the the already head node, that is this, connect this, and then you will move this head from here to this n, which is 2818, and there you go, you did insert at head, okay? Let's say you want to do insert at tail. That means there you need to do the insertion. At that case, what you will do? You will go to the last node. From the head node, you will come to the last node, and then you will create the node here. And let's say your address is 1000. Your data is 1000 that you need to add. In that case, this will be already by default null. In that case, you will travel to the last node. Once you travel to the last node here, what you will say? You will just connect this node with this node, and to do this, let's say if this is 2833, you will rub this null and you will just write this 2833 here, and this node gets connected to this, and already that is null, so it is going to be the insert at tail, and this is how you will be able to insert the element at tail, and this is how you are gonna work with this, guys. I hope that this is very much clear. So today what we learned the insertion of head, tail and position, and we understood how you can create a linked list. Well, code part of this linked list I will show you in the second part of this video. In this part of the video, I would just wanted you to understand what is linked list first, and how the linked list is different from an array, traditional array, and what is a linked list exactly, how it looks like, and what is the use of a linked list. So I have told you that. I hope that this video is very much clear to all of you guys. If you like this video, give us a thumbs up. If you have any doubts, you tell us in the comment section below. I will try to clear your doubts. In the next part of the video, we are going to understand how to code this linked list into our code in C++, and we'll understand various different uses. Once we finish with this, we are going to start doing different questions on linked lists, which are generally asked in interviews, and we are going to see all the different types of questions. So that's it for this video, guys. Thanks for watching. Don't forget to like, share and subscribe to our channel Coders Arcade. And that's it for this video, guys. This is Ashank David signing off. I'll see you guys in the next one.